Sea turtles return to the beach where they were born with extreme precision to lay their eggs. But island beaches are vulnerable to sea level rise due to climate change, which has accelerated during recent decades. Many coastal species and habitats around the world are being affected. Now, a study finds that sea level rises could lead to the flooding of sea turtle breeding grounds in Australia, Dominican Republic, Costa Rica and the US. Researchers estimated the probability of flooding under moderate and high greenhouse gas emission scenarios between 2010 and 2100. At 2,835 sea turtle nest locations within 7 breeding grounds. Breeding grounds were located in Costa Rica, Cuba, the Dominican Republic, the coast of Ecuador, Raine Island off Australia, St. George Island off Florida, and St. Eustatius in the Caribbean. The breeding grounds were used by 5 sea turtle species: leatherback, loggerhead, hawksbill, olive ridley, and green sea turtles. The authors found that under a moderate emissions scenario, breeding grounds located on flat beaches were most vulnerable to flooding, with 100% of nests located on Raine Island and the Dominican Republic's Saona Island. Within breeding grounds at low elevations on flat beaches, estimated to be vulnerable to flooding by 2050. Within breeding grounds used by multiple turtle species, the authors estimate that leatherback turtle nests may be particularly vulnerable to flooding, due to differences in the nesting locations preferred by each species. Leatherback turtles tend to nest in open areas near the high tide line, while hawksbill and green turtles tend to nest at higher elevations, closer to dunes and steep cliffs, because female sea turtles return to nest on the same beaches where they hatched. The authors speculate that sea level rises may result in many turtles nesting on flooded beaches, reducing the number of turtles hatching. They point out that the long-term effects on sea turtle populations are currently unknown. More research is needed to determine how quickly turtles may adapt to flooding of nesting habitat. The findings highlight the need for strategies to mitigate the impacts of sea levels rises and enhance sea turtle resilience, such as sand refilling on nesting beaches, nest relocation, and the use of turtle hatcheries.